All right, so we're going to look at Exam 3 in class review. So this would be the review we do in class. So find the accumulated value of an investment of $6,000 for 5 years at an interest rate 6% if the money is compounded weekly, continuously, and which investment is better and why. So for Exam 3, we are looking at the things we need to know. There's a formula we need to do. First of all, there's one for the accumulated value with an interest and a number of things that are happening, and then there's one with continuously. So compounded weekly, we'll use one formula. Compounded continuously is another formula. So for part A with compounded weekly, we're going to use A is equal to P times 1 plus R over N raised to the NT. So we need to know what the P is, what the R is, what the N is, and what the T is. So let's go back to our problem. Value of an investment of $6,000. Well, that's your principal. That's $6,000, the amount you invested into it. For 5 years, that's your time. At an interest rate of 6%. Well, that's your rate of 6%. Remember, you have to change that to a decimal at 0.06. Now, we need the N. Well, the N comes from compounded weekly. Weekly would be 52. Monthly is 12. Quarterly is 4. Semi-annually would be 2. So think about a semicircle, a semi-annual sale. For quarterly, think about 4 quarters in $1, 4 quarters in a football game, things like that. Monthly, of course, 12, because there's 12 months in a year, and weekly is 52, because that's how many weeks come in a year. So now what you need to do is set this up in the formula. So A will be equal to 6,000 times 1 plus 0.06 over 52 raised to the power of 52 times 5. Now, at this point, you're going to put it in the calculator. I don't care which calculator you have. This is the one I'm going to use, but you can also do this calculator. Either one works. So let's put it in here, and then so 6,000, parentheses, we're following the formula right there, of 1 plus 0.06 divided by 52, close your parenthesis, and then the rooftop key right here, raise it to the power of 52 times 5. Now, I have a box when I did mine, so let's back up just a second. So when I raise it to the power, I get a box. So I can put in 52 times 5. If you have one of the older calculators, like the old TI-84s or TI-83s, if it doesn't give you a box, you have to put that whole thing in parentheses. Otherwise, it would only raise it to the 52 and then multiply the whole thing by 5. So you can put that in parentheses and then just hit enter. Now we're going to go to 2 decimal places because it is money. So this will equal 8,097.75, and we'll put the dollar sign. All right, so that's the first part. Let's look at part B. Part B is using A equal PE to the RT. So it's going to use a lot of the same values. So P is still 6,000. E to the R, that's still 0.06 times T, which is 5. The only one you won't use is the N because it doesn't have an N. And again, let's go put that in the calculator. So 6,000. Second, E to the X to get the E to the box. So 0.06 times 5. Again, if you don't get a box, you've got to use parentheses and then hit enter. So we're getting 8099.15. So which one is better? This is part C. Better? Well, the one that's better is this one, the continuously. And why is that? Because you made more money. So I'm just getting you to look at your answers. All right, next problem. We're looking at log base 7, 343 equals 3. It says to write the equation in equivalent exponential form. So number 2, we've got log base 7, 343 equals 3. So that this is in log form. We need to write it in equation form, or in exponential form, sorry. So that becomes 7 to the third equals 343. That's it. Okay, the third problem says to take 8 squared equals 64 and write it in log form. Well, this becomes log base 8. Notice in both of these, those values stay the same. And then it looks like these two swap. Visually they do, mathematically they don't, but visually they look like they swap, and so will these. So it'll be log base 8 of 64 is equal to 2. Okay, on number 4, it says to evaluate or simplify the expression without using a calculator. So this is e to the ln of 7x. And we know that through the knowledge that we gained doing the lessons that e and ln undo each other even when they're raised here, because this is ln, the base of that is e. So they will undo and it'll just be 7x. On number 5, we have log base 9 equals 1. Well, or we just have this. We have to find the answer. This is the base of 9 for 9, so it's going to equal 1 whenever these equal each other, because if we take it to exponential, 9 to what power would equal that 9 right there, just like we did before. Well, it has to be 9 to the first power to equal 9. And so that is where we are landing. All right, let's go look at number 6. So for number 6, we need to expand as much as possible log base 8 x cubed y to the 8 divided by z to the 5th. I needed to bring this down just a little bit further. I drew it a little too soon. All right. So we want to expand it as much as possible. So remember, the division becomes subtraction and multiplication becomes addition. So the first thing we're going to do is do the subtraction part. So log base 8 x cubed times y to the 8 minus log base 8 z to the 5th. And when you expand it, that log comes with it. Now, x cubed and y to the 8th become addition, so log base 8 x cubed plus log base 8 y to the 8 minus log base 8 z to the 5th. The last step is to move the exponents. So you get 3 log base 8x plus 8 log base 8y minus 5 log base 8z. Now, if you can see it, you can take it straight to that. But if not, you can work it through the steps, because I could do this. So you can do that if you want to on the exam. All right, let's go do another problem. So number 7, we are expanding. Oh, and to just give you an idea, if you were going backwards, this would expand back the same way. So put the exponents and then put your parts back together, like put the multiplication back together before you throw the division back under. All right, so we have 2 log base 4x plus 5 log base 4y minus 7 log base 4z. So the first thing I have to do is put my exponents back. So log base 4 x squared plus log base 4 y to the 5th minus log base 4 z to the 7th. Combine my multiplication, or my addition to multiplication, so log base 4 x squared y to the 5th minus log base 4 z to the 7th. And then that becomes my division. So log base 4 x squared y to the 5th divided by z to the 7th. And again, if you can put it all back together in one step, I'm okay with that for this one. All right, number 8, we need to do change of base. So log base 6, 31. So we're going to use common or natural logs in a calculator to evaluate the following logarithmic expression to 4 decimal places. Show work. Basically this is, so log base 31 over log base 6. It's the change of base. So that way the calculator recognizes what you're doing. So we're going to take log base 31, close your parenthesis, divide by log base 6, close your parenthesis, and go to 4 decimal places. So 1.9165, the 4 won't move it up. So it will be 1.9165. All right, number 9. Number 9 tells us to solve the exponential equation. So 2 to the x plus 3 equals 16. Well, in order to do this, you're going to have to get it to the power of the same base. So 2 is the lowest it can go for a base. We can rewrite 16 as 2 to the 4th. So 2 to the x plus 3 equals 2 to the 4th. So that, if 2 to this power equals 2 to that power, then those powers have to be equal. So x plus 3 has to equal 4. Subtract your 3 over, and you get x is equal to 1. All right, number 10. So for number 10, we are solving the exponential expression, and we want to find the solution in terms of natural logs. So we have 6 to the 3x equals 35. You know that this is not power of the same base because 6 and 35 can't get to the same power. So you're going to have to use natural logs. Also, we have an exponent with an x, so the only way to get that down is to use our natural logs. So we'll take the natural log of both sides. That means I can move my exponent up front with expansion. So 3x ln of 6 equals the ln of 35. Now I want to solve for x. I'm going to divide by everything that is not x. So x will equal the ln of 35 divided by 3 ln of 6. And just solving it in natural logs would be that. If you were asked to find the decimal, put it in the calculator and find a decimal. But that's not what the instructions said on this one. All right, number 11. So we have the log base 7 of x minus 5 equal to 2. We are asked to solve the logarithmic equation and give the exact answer. So we're going to change this to exponential form. So 7 squared is 49 equal to x minus 5. Add your 5 over. 49 plus 5 will get you 54 equal to x. And that's all you got to do. All right, number 12. Number 12 says to solve it, the logarithmic equation, and again give the exact answer. We're given log of x plus log of x plus 2 equals log 15. All right, so the first thing we need to do is combine these together. It's addition, so it becomes multiplication. So the log of x times x plus 2 will equal the log of 15. Well, if the log of this equals the log of that, then these two parts have to be equal to each other. So that means x times x plus 2 is equal to 15. But you have to combine them together first, and I have to see this step. Otherwise, your math is not quite right. Well, x times x will get me x squared. X times 2 is 2x equal to 15. Move the 15 over. So x squared plus 2x minus 15 is equal to 0. We need to factor this. It's going to become x plus 5 times x minus 3 equal to 0. So x plus 5 equals 0 and x minus 3 equals 0. X will equal negative 5 and x will equal 3. Now this is where you have to remember your log rules. You can't take the log of a negative number. If I plug in negative 5, I'm taking the log of a negative here and one here. It only has to happen one time. If it happens at all, you can't use it. So this one doesn't work. If I plug in 3, I'm taking the log of 3 and the log of 5. That one will work. And you have to show me that you canceled out the one that doesn't work, or you're going to lose a point on the exam. All right, next question, number 13. So for 13, we're solving, given the formula of A is equal to 15.8 e to the 0.0134 t, models the population of Texas in millions of years after 2010. So part A asks, what is the population, or what was the population of Texas in 2010? So we have to do t is equal to 0 because it's after 2010, then the year in 2010 would be 0. So you have to show me that plugged in. So A would be equal to 15.8 e to the 0.0134 times 0. Well, anything raised to the 0 power is 1, so it will be 15.8 million. But I want to see how you know that, so make sure you show me that 0 part. Part B asks for the rate. Well, this part right here, the formula is the rate. So 0.0134, which actually equals 1.34%, because you move the decimal places 2 places to the right. Now for part C, we are asked to find how long it will take for the population of Texas to reach 26 million. Well, that means the total population is 26, and we're finding out the year, so 0.0134 t. So I'm going to start out by dividing by 15.8. So 26 divided by 15.8 will equal e to the 0.0134 t. Now, I'm not going to do anything with that. I'm just going to leave it be. I'm not going to change it to a decimal or anything, because you don't want to round too soon. Now to clear this, I need to take the ln of both sides so I can get the t out. Remember, ln and e will undo each other. So the ln of 26 divided by 15.8 equals the ln of e to the 0.0134 t. Well, those will undo each other. So the ln of 26 divided by 15.8 is equal to 0.0134 t. To solve for t, we'll divide by 0.0134. So t will equal the ln of 26 divided by 15.8 divided by 0.0134. And that'll get us like 37.17, which will be 37 years. Whoops, can't see. Sorry about that. So 37 years is how long it takes. If they're asking when, if you get asked when, you have to then take 37 and add it to 2010. But this is just how long will it take. So we're just looking at the how long part. All right, next problem. So number 14. For number 14, we're going to solve using systems of equations. The Metropolitan Theater is selling tickets for a premiere opening of a play. They charge $14 for adults and $9 for children. A total of 486 tickets have been sold, totaling 5104. How many children's tickets were sold? So the first thing you got to do is figure out what your totals are. We have two totals and we have $2 amounts. So pick a ticket. You've got to pick two variables for your tickets. You can use adult and children, so A and C, or X and Y. Usually you guys like X and Y. So totally we sold 486 tickets of the two types. And then with the cost, one was 14 and one was 9, and the total that we made was 5104, or that was brought in. So you have to set the two equations equal to the two totals. Now once you do that, you have a system of equations. You want to solve for one of the variables. Now I'm going to solve for both children and adults. It asked how many children tickets were sold, but sometimes you got to know both. So I'm going to solve for both, and then you can go from there. So if I want to solve for both, I need to get rid of one. I'm going to solve for the x first because the 9 is a smaller number, and that way I won't end up with so many negative signs. So I'm going to multiply this one here, bring it down, and I'm going to multiply by 9. Okay? So that, by negative 9, so I can subtract it out. So negative 9x minus 9y will become equal to negative 4374. So I multiplied all three by negative 9, and that will get me 5x is equal to 730. So I took these two equations and combined them together. Now I'll divide by 5, and x will be equal to 146. Now these were the adults because of the price. So to find the children's, I can take 146 using this equation plus y equals 486. Subtracting the 146 over, I get y is equal to 340 children. And there you go. So how many children tickets were sold? 340. But if you're asked to find both, you can. All right, next problem, number 15. For number 15, we're evaluating a determinant of 7, 3, 6, 8. So we're going to go 7 times 8 minus 3 times 6. Well, 7 times 8 is 56. 3 times 6 is 18. And that will leave us with 38. That's all you got to do for that one. Okay, number 16, we are given a system of x plus 2y equals 11 and 3x minus y equals 5. And we are told to solve it using Cramer's rule. So for Cramer's rule, we have to find the d, the dx, and the dy. So the d comes from right here. So the d will be 1, 3, 2, and negative 1. It's the coefficients right here on your equation. So we're going to do it just like we did the previous problem. So 1 times negative 1 minus 3 times 2. So 1 times negative 1 will get us negative 1. Minus 6 will be negative 7. Okay, let's find dx. So for dx, we'll replace the coefficients of x with the ones on the equal sign. So 11, 5, but the y's stay the same, so 2, negative 1. So 11 times negative 1 minus 5 times 2. So that's negative 11 minus 10 will get us negative 21. For dy, the x's go back to the original and the y's become the coefficients, or the numbers on the other side of the equal. All right, so we have 1 times 5 minus 3 times 11. So 1 times 5 is 5, minus 33 will get us a negative 28. So remember that x is dx divided by d. Think about how the d's cancel. They don't really, but if you cancel them out, you get x equals x. So dx was negative 21 divided by d, which is negative 7, will get you 3. And y would be dy divided by d, which will get you negative 28 divided by negative 7, which is 4. Now you have to write the final answer in this format. You have to write it as the points because the solution is a particular point. And so you need to write it that way. If you don't put that, I will take off a point. All right, now we're going to take the same problem and we're going to work it doing a matrix. So we have, this will be number 17. So we have the same system that's sitting right there. So we have x plus 2y equals 11 and 3x minus y equals 5. But this time we're going to use matrices. So let's set up the matrix to begin with. So I've got 1, 2, 11, and 3, negative 1, and 5. So that's my matrix. And I need to solve, so I've got to get a 0 down here and then a 1 right there. So in order, remember you can only use addition and multiplication. So in order to get this to be a 0, I have to subtract 3 from it. And I'm starting there because I already have a 1 in the top corner. If I didn't, I'd have to get the 1 there first. So I can multiply negative 3 times 1 and get negative 3 minus 3, or negative 3 plus 3 and get to 0. So we'll take negative 3 times row 1 plus row 2 to get our new row 2. So that will be negative 3 times 1, negative 3 times 2, and negative 3 times 11. So that's all of row 1. So that gets us negative 3. Negative 3 times 2 would be negative 6, and negative 3 times 11 would be negative 33. Now I'm going to add row 2 of 3, negative 1, and 5. So negative 3 plus 3 would get me 0. Negative 6 minus 1 is negative 7. Negative 3 plus 5 would be negative 28. So my new matrix is now, row 1 is the same, 1, 2, 11, and row 2 is now 0, negative 7, and negative 28. Now I have to get negative 7 to become a 1. So what I can do is basically divide by negative 7, but we can't divide. We're going to multiply by negative 1 over 7. So now I can take negative 1/7 times row 2. That becomes my new row 2. So I'll have negative 1/7 times 0, and then negative 1/7 times negative 7, and negative 1/7 times negative 28. So anything times 0 is still 0. This becomes 1, and this becomes 4. So as I rewrite my matrix, I end up with 1, 2, 11, and 0, 1, and 4. So what this tells me right here is that this is x plus 2y equals 11. We didn't change the first equation at all. It's still the same. And this is just a y equal to 4. So now I can plug 4 into that first equation and get x plus 2 times 4 equals 11. So x plus 8 equals 11. Subtract the 8 over, and x will equal 3. We still end up with the same answer, but you should know how to do it both ways. Same problem, same question. Or same answer, just different methods. All right, let's look at number 18. So number 18 asks us to solve the system by using any algebraic method. So this is a 3 by 3. It's x plus y minus z equals 1. 2x minus y minus z equals 9. And x plus y plus 3z equals 5. Now you can solve this any way. You can solve it using systems of equations. You can solve it doing Cramer's like we just did, or solve using matrices. But you need to look at the problem and see which one's easiest for you to do. I think adding them together is the easiest because it has the y's. We have positive y, we have negative y, and we have positive y. So if we use the system of equations, then we can actually cancel some things pretty quickly. So what we're going to do is we are going to take the first two equations and just add them together because the y and the negative y will cancel. So I'm just going to bring them straight over and do nothing to them. So x plus y minus z equals 1. 2x minus y minus z equals 9. As I add those, I'm going to get x plus 2y, or x plus 2x will be 3x. The y's cancel, and I end up with negative 2z equals 10. Now what I'm going to do is take the last two equations and add them because I need the negative y and the positive y. Without rewriting them, I'm just going to come over here and do this and understand I am just adding those together. So we get 3x, the y's cancel, 3z minus z will get me plus 2z is equal to 9 plus 5 is 14. Notice my z's, I put a line in so you can tell the difference between a 2 and a z. Now I have two equations. Well, if I just add these, this one's actually really simple. I don't have to multiply by anything. I can just bring it straight on over. So if I bring this one right on over, 3x plus 2z equals 14. My z's will cancel. I have 6x. Z's cancel out. 10 plus 14 equals 24. Divide by 6 and x will equal 4. So now that I have x, I can use any of my two equations to find z. I'm going to go ahead and use this one for ease. It wouldn't matter. So I have 3 times 4 plus 2z equals 14. So 12 plus 2z equals 14. Subtract my 12 over, and I get 2z is equal to 2. Divide by 2, z equals 1. Now that I have z, I can use any of my equations up here to solve for y. So when I look at them, I want a positive y, so I don't have to divide by negative 1. Looks like this one's probably the easiest one. I don't have to multiply by 3, so I'm going to use that first equation. So x plus y minus z equals 1. So x is 4 plus y minus z equals 1. So 4 minus 1 would still leave us with 3 equals 1. Subtract the 3 over, and y is equal to negative 2. So now that I have the x, the z, and the y, I can put them in order. So x has to come first, then negative 2 for y, and 1 for z. Again, you have to show that answer or I will take a point off on the exam. Again, you can solve it any way you want, but you can see this one is actually pretty simple to solve with the systems of equations.